Hour 3, session 3 of track 1. Welcome back here with me and Floor. I know that you're going to love our next speaker, Floor, because I know that you're a bit of a Terraform fan and a bit of a HashiCorp fan. So next up, we've got Ravi Mandal, who's going to be talking to us about infrastructure as code, which is also one of my favorite topics. He is going to cover how we build and deploy infrastructure using Terraform in Azure and integrate it into your CI/CD pipeline. Ravi does a whole bunch of stuff. He's a Microsoft MVP. He's part of the ASP.NET communities in Nepal. He does some cloud engineering work with the Xamariners. I can never say Xamariners. Xamariners. It's too much for my Australian tongue. So on that note, I'm going to throw straight over to Ravi. Make sure you throw some questions for him in the chat, and away we go.
Yep. Thanks very much. Let me share my screen. Yep, I hope you can see it.
Perfect.
Okay, yep. So hello everyone. It's lovely morning in Nepal, and I'll be talking about infrastructure as a code on Microsoft Azure with Terraform. So I have a bunch of slides first, and like a couple of them, and then we'll talk about the theory of infrastructure as a code, and then what is Terraform, why do we need to use Terraform and stuff for the first few minutes, and then we'll straight jump into the demo. I have so much demo to actually show you around, but let's see if the time permits or not. But yeah, if everything goes fine and the time permits, we'll end up with a CI/CD pipeline that can actually execute Terraform and create resource in Microsoft Azure. So first of all, a little bit of context. I'm Ravi Mandal from Nepal, and the country of mountains and Mount Everest. And I work as a cloud engineer at Xamariners. It's a Singaporean company, but I work from Nepal. So I work remotely. I've been working remotely for last 1 year, and I'm Microsoft MVP on Azure. Also, I'm a certified developer, Microsoft certified Azure developer associate. If you want to find me, you can find me at Twitter at RaviMandal47. You can find me at Ravi Mandal, and I recently started a YouTube channel, but I haven't been so much consistent about that. But I'm trying to be consistent. You can search my name and you can find me there, or you can also visit my blog that I recently created. So yep, this is how you can reach out to me. And this is the today's agenda that we'll be talking about today. So the first thing that we'll talk about is a very basic thing, that is we'll talk about what is infrastructure as a code, and then we'll talk about why do we need infrastructure as a code, and then we'll jump into Terraform directly. We'll talk about a little bit theory of Terraform. That's the terms, files, and directory, basic CLI commands of Terraform, and then we'll see how we can use Terraform with Microsoft Azure. And then at the end, if time permits, we'll talk about how Azure DevOps pipeline can be integrated with Terraform. So let's get started at the first thing, that is what is infrastructure as a code. So this is the definition given by Microsoft. Infrastructure as a code is the management of infrastructure, networks, virtual machine, load balancer, or connection topology. It could be anything as an infrastructure, and in a descriptive model using the same versioning as a DevOps team used for the source code. So what does that mean? So let's take an example. So if you're writing some code and you are compiling it, maybe it's a C# code or it's a Java code, and if you throw the same code to the compiler, it will always create the same binary, and it will always be the same. It will never change if you throw the same code to the compiler. It's the same with the infrastructure as a code. It's a list. It's a set of files that you will throw at it, and then it will create the same environment no matter how many times you do it. So that's a similarity between a source code and the infrastructure as a code. So it kind of evolved to solve the problem of the drift of environment in the release pipeline. So one of the principle of infrastructure as code is idempotency. So that means that the target environment will always be the same regardless of the starting state of the environment. So if you throw some configuration or throw some commands to the environment, it will be the same regardless of the starting state of the environment. And also it enables DevOps team to test application in production-like environment early in the development lifecycle. So sometimes what happens is we have multiple environments, dev, staging, and then we have production. what you want to do is you want to make sure that all the three environments are identical to each other, so that if you deploy something, it will be the same. It will be the same, and it will work same across all the environments. So you can test production like environments in the devs using infrastructure as a code. So there are two types of infrastructure as code. One is declarative and another is imperative. So declarative approach focuses on what the eventual target configurations would be. So it doesn't matter how does it do it. So it's like it's a desired state that you want to create in a specific environment, and you just create infrastructure and code using that approach. So it will do all the lifting and shifting for you, and it will create the infrastructure for you itself. So you don't have to worry about how it's being done. But in the imperative approach, it will focus on, you'll have to focus on how the infrastructure needs to be changed using different set of tools. So if you're talking about tools, the different tools could be for declarative, it could be Terraform, Pulumi, Ansible, and then for imperative approach, it's Azure CLI with Bash or PowerShell. So there are two types of approaches, but we'll talk about declarative approach using Terraform today. So let's talk about why do we need infrastructure as a code. But in an environment where there is no infrastructure as a code, the team must maintain the settings of all the environments manually, and that means that everything needs to be done manually, and there is no automation. That could create a snowflake. So snowflake is a unique configuration that cannot be reproduced automatically. So what happens is if you manually configure environments, it could be out of state. It could be out of sync with one and each other, and that could be difficult to reproduce or something like that. So, and the most thing is the inconsistency that you bring among all the environment. So that could lead up to deployment problems and issues. So if you have snowflakes, then the administration and the maintenance of the infrastructure becomes hard to track and contribute to. It could contribute to errors. So it's better to not introduce in snowflakes. So that's why we need infrastructure as code. So infrastructure as code, we can deliver stable environment rapidly at scale, and we can avoid manual configuration of the environments, and then we can enforce consistency across all the environments. And also the deployments are repeatable. So if you create an environment today, you can destroy it and then recreate it again, like in matter of seconds. I'll show that in the demo today. But yeah, so if you write infrastructure as a code, then the deployments will be repeatable, and it could prevent issues about caused by the configuration drift or missing dependencies. So yeah, that's about why do you need infrastructure as a code. And let's talk about Terraform now. So Terraform is a tool developed by HashiCorp. It helps us to reliably deploy and manage infrastructure across one or more clouds, even on-premise. So it's not that Terraform can only be used with Azure or Azure only. So it could be used in AWS, it could be used in Google Cloud, it could be used in on-premise service. So Terraform is just a tool that will allow you to create resources across multiple environments. So so this is something that I got from the Terraform's website. So you can, as I said, you can write declarative configuration files. It's a declarative approach instead of imperative, and you can collaborate and share configuration across your teams. And it's you can version your infrastructure the same way that you can version your code. So, and the provisioning is automatic on that. So then the best thing about using Terraform is planning and the predicting changes. So for example, if you need to change some settings in the load balancer of your infrastructure or something like that, then you just go. If you do that manually, there is no track of changes. There could be no track of changes and whoever changed or something like that. And also you never know what will the end result be. But if you use Terraform and like you do it, you can just type in Terraform plan, and it will show you everything that will be changed in the upcoming application of the infrastructure as code. So we'll see that in the demo as well, but it's a pretty good feature of Terraform that makes it stand out among all of them. So the next thing is create reproducible infrastructure, and the part that I want to focus on here is it's not just Microsoft Azure. You can use AWS, Google Cloud Platform, VMware, Kubernetes, and like 200 more providers that you can use using Terraform. So in Terraform, there's a concept of providers. So providers would be the end provider where the infrastructure will be applied, and it will be the environment will be created. So you can use multiple providers in Terraform that you can look at the Terraform documentation and see. So yep. So let's talk about a little bit theory of Terraform. Then we'll jump into demo. So the first thing is Terraform file. So Terraform file is a .tf file extension that will contain the code of infrastructure. The Terraform project is a directory of the folder that contains Terraform files and is a part of infrastructure development. Resources, the primary construct in Terraform. So these are things like storage account, virtual machine, and the infrastructure stuff that you create on the environment. And providers, as I talked about, that plugins that will create that will allow us to create resources in Microsoft Azure or AWS or any other services. So the other thing is variables. So if you are a coder, if you are a programmer, you know like the power of variables that you can use. So you can use the same thing in here as well. We'll see that in the demo. So variables, we can create variables and then reference that variables across multiple places. So that's a beauty of it. And then it's the other is input variables. So input variables are things that you pass in into the CLI command while trying to execute it. And module is the directory or folder that you can reuse across multiple Terraform deployment projects. Yep. So Terraform code is actually written in IaC configuration language, HCL for start, and then it's stored with .tf extension. So the TF file could be broken out it could be a single file, or it could be broken out into multiple files that will reside in the same directory. And if that is in the same directory, while applying the configuration, it will combine all the files that you have, and it will create the infrastructure using that. So that's how you can store it. So the best practice would be to create multiple files and then like segregate the different commands and different things that you have to use in multiple files, so that it will be maintainable as well as trackable. So yeah, so those are like basic terminology that we need to understand in Terraform. So let's see at the basic CLI commands. Terraform init is to initialize Terraform in a current directory of Terraform files. So it's like git init, something like that. Terraform plan will give you a understanding of what will be the execution and what are the resources that will be created in the infrastructure or environment. And Terraform apply, as the name suggests, it means that the infrastructure as code will be applied in the environment, and it will go ahead and execute all these. It will go ahead and execute the whatever you have defined, and it will create the resources. The other is Terraform destroy. You don't want to do that in production, but yeah, if you want to delete all the infrastructure that were previously deployed using that, so you can use Terraform destroy to delete all of the resources that were created. It's a bit easier for us who has to do a lot of demo and create multiple infrastructure and stuff. I can just create infrastructure with code and then just write Terraform apply and then create it. And then if I don't want it, I can just say Terraform destroy. So yeah, you have to be careful on that. But yeah, it will tear down the infrastructure. But yeah, it's possible to do that as well. And Terraform dash adds, like as the name suggests, it means that you can create you can look at the help of the Terraform and see if you have doubts in Terraform CLI commands. So yes, so this is it for the theory. I'm a more demo guy, so I'll focus on demo. So I have a pretty good demo, so that I'll show. So let's get started on that. So first and foremost, that you'll need to do is so I have a terminal. I have already installed Terraform. I'm not going through how you'll install. You can just look at that in the documentation. But yeah, you'll need to have, if you're using Terraform with Azure, then you'll need to have Azure CLI and then Terraform installed. So I have Azure CLI installed, and I can show you that I have already logged in. Yeah, I've already logged in using my personal Azure subscription, and then if you don't know how to log in into Azure CLI, then you can just say AZ login, and then it will redirect you to a browser, and then you can log in, and then it will get all of your credentials. So since I'm already logged in, I don't want to do that. And so, yep. So I'll create a folder. We'll start from scratch, so it's easier to for you to follow if you are following it in the future, since this session will be recorded. I'll create a folder. Sorry, not create. Make the TF demo VACD. Yep. So that's a folder that I'll create. Yep. So I have it's an empty folder. So I'll open that in Visual Studio Code just to make it easier. Yep. So I hope my screen is zoomed in. Yep. So I'll create a new file called main.tf. As you talked about it, like you can create multiple files in Terraform and then declare the infrastructure there. So I'll create a main.tf file, and then I'll create a providers.tf file. So in providers, I'll define which provider that I want to use. So for that, I'll use Azure RM provider. So that will allow me to create a provider that will allow me to use Azure as a provider and then create resources there. And then I'll in the main.tf, what I'll do is I'll try to create a resource group. So if you're familiar with Azure, you can create, you have concepts of resource groups, and then you can have multiple resources inside there. So what I'm doing here is what I'm saying that I want to create an Azure RM resource group. The internal name will be RG, and the name of the resource group should be VACD RG, and the location should be Southeast Asia. So here I'm trying to say is my provider is Azure, and then I want to create a Azure resource group. So let's see how to apply that. What I'll do is first I'll do Terraform init. That's the command that we saw. So what init will do is it will look at the providers that you have mentioned, and it will try to download it and store it in your local, and then it will initialize the directory for creating resources. So if you look at my resource group, there is no resource group called VACDRG. So that this is to show that I'm not lying. And yes, so I've just done Terraform init, and then I'll do is Terraform plan. So Terraform plan will give me a plan of what will be the next state of the my environment, and it will show me how what will be created. So it might take a time depending upon your configuration and whatever it is. So since it is a very small change in my case, it will just create a resource group. It is saying that want to add, and then it will create the resource group there. So what I'll next do is do Terraform apply. So Terraform apply will create the resource that you have mentioned, and it will do according that you have planned. So it says that it will create a resource. That's what it will do. It asks me for a confirmation, but you can also send a auto approve flag to turn off that if you're working in a headless environment. But if you're working in environment where like you are just not passing that flag, it will ask you for a confirmation. So it says the resource has been created. Let's see that. I'm not sure what the problem is, but from the morning I'm getting an issue where the resources doesn't get refreshed. Yes, so there it is. So the VACD RG. So there is a resource group that has been created, and it's there. So now we talked about variables and stuff, and like we are hard coding names and hard coding locations. Like it doesn't sound that good to me. So what I'll do is now I'll create a variable. So I'll create a file called variables.tf, where I'll define variables. Variables that I'm going to use. So in this case, I want to create a variable called RG name and location. So and after that, this is just the name of the variable. But what I'll also want to do is I want to create I want to define a value for that. So for that, I'll create a file called dev.tf vars. So that will allow me to give the values of the variables that I mentioned. So in tf vars, I'll define the actual value of it instead of directly harding code in the main.tf file. And then in the main.tf, what I'll do is I'll change this to use the variables instead of using the hard-coded value. So now we have changed something in the infrastructure as a code, in infrastructure code. But let's see if what happens if we do Terraform plan. So Terraform plan, it is asking me for the variables value of the variable, because it doesn't know which file to pick up for the variables. It doesn't automatically pick up the TF var files. You'll have to mention that. So for that, you'll have to do is Terraform plan var file, and then give the name of the file. So it will use that file, and it will use all of the values that you have defined in the files, and replace that with the variable, and then it will look at these and it will execute the command. So for now, we have just changed something in the code, but the desired state of the infrastructure is the same. There is nothing to change there. So it says no changes, because we are just changing in the file. We are not making any change in the infrastructure. So now let's create something new. So we'll add few variables. I'm just copying and pasting it from my previous demo. So variables, we'll define few new variables. So what we'll create here is we'll create app service plan. We'll create a web app there, and then we'll create application inside, and we'll create application type. We'll create application inside there. So I'll be using these variables. And for these variables, the values are I'll mention that here. So the values would be these. App service plan, the name would be plan tf demo dev. The web app name would be app tf demo dev. The application insight name would be API tf demo dash dev, and the AI type would be web. So I'll be using these. But if so, these are only the variables that we have defined, but we have not actually tried to create a resource there. So what I'll do is I'll copy and paste it from the but I'll still explain. So so let's go through this one by one. So first thing that we're trying to create here is app service plan. So app service plan is where the app services reside, and where you can create websites, you can create Azure functions and stuff. So you'll need an app service plan first before creating the web apps. So first we are going to create app service plan. I am referencing the app service plan name from the variables. But see what we're doing here. We are actually referencing to the name of the resource group that was created from the previous step. So we don't have to hard code each and everything. We can reference at the previously created resource, and then use the values of that. So for example, if this resource group had some other let's say maybe you need an ID of resource group, then what you could do is you could do resource group.id, because ID is something that will be only be known after the resource group has been created. It won't be known to us before we create the resource group. So in those scenarios, it is very helpful for us to code, and like it's similar to how you reference stuff in the codes if you are a programmer. So but still yep. So and what I'm saying is we're passing a property saying that the SKU for the app service plan should be basic and the size should be B1, right? Now we're done with the app service plan. We will create application insight resource. The internal name would be API, and the name is reference from var, the variables that we have defined, and the name. So it will use this name. It will use this name and then like create the resource. So similar to that, we are referencing the name and the location of the resource group from the resource that was created here. And then after that, we are creating an actual website. So let me remove this for a while. I'll show this in the next demo. So yeah, I'm creating an app service, and then the internal name would be website, and the name of the website is been referenced from variables, and then the resource group. Then the resource group name is actually being referenced internally, and then you can see here that we're referencing the plan ID from the internal resource that we created. So we are actually referencing from the step above creating this website. So as I said, ID is something that is unknown to us before writing the code. So it can be only known to us during the runtime. So we can actually reference that directly. And then, yep, so we're creating three resources here, app service plan, app insight, and the website. So there are a few changes here that we have done. Now let's see what happens. So if I do Terraform plan -dev.tf vars, then it will compare the state of that I was in previously to the state that I'm trying to apply, and it will look at the delta that is required, and then it will give me the list of changes that needs to be done. Yes. So if you look at here, these are the resources that will be created, and you can create a approval pipeline for these, so that you want to make sure that the changes that the infrastructure team is doing, it's okay. You can review it before even applying it. Till now, we have not applied it. So if you want to apply this, we just change it from Terraform plan to Terraform apply. So it should take a while to actually apply it, but it will create multiple resources in the infrastructure and create it. So if you look at here, it will start creating it. It should take a while, just a minute maybe. Oops. Yes, I want to create the resources. So as you can see, it's trying to create app insight. It's trying to create the app service plan, and it should be live in a while. Yep, still creating. So while it's being created, I want to give you a quick look on TF state. So TF state is something that it will store the state of the environment that you are currently in, and then it will apply the state to the next desired state that you want to be, and it will keep all the backups and stuff. But the problem here is it's all stored in my local. Like, what if I have to share with multiple teams? I have to work with multiple teams. I need to share it across my entire team. So that is something that I'll cover up in the next demo. But yeah, so everything that you're seeing here is being stored in the TF state. As you can see, it just reset my TF state to something that the current environment is in my Azure. So if I look at the CLI, it says the apply has been completed. 3 resources were added, 0 changed, and 0 destroyed. Right. So let's go and see here. So if I refresh it, that's what we're seeing. We said we are creating an app service plan. We said we are creating application inside, and we said we are creating app service. So all of these happened without even going to the Azure portal and then doing it. So we just used whatever the CLI tools that we have, and then created it. So it saves us from click and deploy stuff. So we'll have to go and click deploy. Instead of doing that, you can just define that in the code and do it in a geeky way. So if let's look at the website. So currently we have a state where it says, okay, you don't have permission to view this directory or page. But if you see here, hosting start.html, it does have a page. So that means the default page of this site hasn't been configured yet. So that's what we missed. So if you look at the configuration, and then go to default documents, there is none. So we haven't mentioned the default documents. Now, if I was the same person that I was few years back, I would just click it, put hosting start.html, and then save. But yep, we have evolved, so I'm not going to do that. What I'm going to do is I'm going to do it in an infrastructure code way. So this is something like it simulates we're changing some configuration in the system. So I'll go to the main. main the TF file and see where do I need to apply this. So I'll need to apply these on the site config. So that would be default documents. I'm passing an array of strings, and I can also say, oops, I can also say index.html. So this way I can configure the website without even going to Azure portal. Now, if I go to plan, it will give me a plan of whatever things that will be changed. Now, if you see here, it will be a very short list instead of the very big list that you saw a while ago. So it is trying to refresh the state, and it will try to compare the state, and it will give me a plan. Yep, there is one thing to change, and the one thing that needs to be changed in the default documents, it will create hosting.start and the index.html configuration. So what I'll do is I'll say Terraform apply. So it will go ahead and add the configuration in the website. So let's wait for a while. Well, it really depends on the internet connection that you are using. And I tried this morning in CI/CD pipeline, and it was like blazing fast. But looks like my internet is not happy with this traffic. So yeah, it's taking a while. But yeah, it should be fine. We should be all fine because we have already make sure that the changes that we're doing is fine using Terraform Plan. And yep, so it's trying to do something that's taking a while. While this is happening, what we'll do is we'll talk about another concept of Terraform that is we'll talk about Terraform backend. So as I talked about this earlier, let's see if it did something. Yeah, I want to change this. Yes. Finally, it's modifying, and it should be up in a while. Yep, so it's done. So we just changed a small configuration in app service using Terraform. So as we mentioned, we are using we stored hosting start and index.html. So if you refresh the page, it should be there. It should work as it should. So we created an infrastructure. We changed the configuration and stuff. But now, as I talked about it earlier, all of the state that we are talking about is actually being stored in the local. Like, what do you need to do? How you'll do it if you're working with our entire team? Like how do you share the state? Like it's like scaling multiple websites, but like not sharing the state, and then like the different user will have multiple states, and the state is not shared. So it's something like this. So we can use Terraform backend to actually store the state somewhere else instead of storing that in the local. So for backend, we could use Azure, you could use console, you could use etcd, you could use HTTP. There are lots of other backends instead of Azure. But for now, what I've done is I've created a resource group called Terraform, and I've created a storage account. So the storage account will store the Terraform state instead of storing that in the local. So what we'll do is, okay, but before that, let's do one thing. We'll destroy the entire environment. Yep, it took a while to build it, but destroying is like blazing fast. So let's destroy it first. dev.tf vars. Terraform destroy story. Okay, I made a typo. So let's destroy the entire environment and we'll create it again. So while it's being destroyed, yep, it will take a while, I guess. Nope. So yeah, destroying is faster than creating, so that's fun. But yes, like destroying the resource, you should be very careful with it. You should not do that in production unless you're pretty sure about it. So destruction complete after 2 seconds. Okay, so it's destroying the entire environment, and that means it will destroy everything from the resource group. So we don't have to go ahead and like click and delete each and every resources manually. It will just do that automatically. Yep, as you can see, all of the resources are deleted. The resource group should be gone in a while, but yeah, let's not worry about that. So destroy completed. We are able to destroy an entire environment using a command line. So it's kind of powerful and risky as well. So yeah, use it with caution. So we're talking about backend. So if you're trying to share multiple states across multiple devices and multiple places, then you'll have to use backends. For this, I've created a storage account in the Terraform resource group, and then the Terraform resource group contains a container called tf state. So the tf state will hold the state for us. But how do you configure that in Terraform is you go to Terraform and then add a configuration for Terraform saying backend is Azure RM, and then the storage account name is the name. The container name is the tf state. So whatever container that we created in Azure will be used there. So on the key for that is Terraform the tf state. So for now, since I have already deleted the entire environment, I can delete this state from my local, and I'll move that to the to Azure as a backend. So now you must be wondering how it is actually accessing the Terraform the storage account, because it does require access key, right? So it's not a good practice to check in the store secrets in the code itself, in the repository itself. So it's better to segregate that from your code. So to make sure that it works, what I've done is you can use a variable called. So I'm using a variable called ARM access key. So it is the storage account. It is the storage account access key, and it will automatically pick that up and then use it. So I don't have to put that in the code itself, and then I can it doesn't need to be set. So the access key will stay in my local environment, but the configuration will only be pushed to the repository. So now, since it's an entire new state again, because I deleted every resources and the state from my local as well. So what I can do is I can say Terraform init. So now it will use the backend of the it will use the Azure storage account as a backend and store the state there. If you see here, I don't have the state file here. The state file is actually stored in the container that we specified. Okay. Should be there. Oh no, you'll have to first do a plan or something like that. So Terraform plan, let's Terraform plan, then bar file dev.tf vars. So yeah, it says acquiring state lock, and now this will create a Terraform file. So there is a file called Terraform state.tf state. So it's a state that we are initializing. So yep. So yeah. So since we deleted all the resources, it will try to recreate everything once again. So I talked about repeatable creation of infrastructure. So this is what I meant. Even if I destroy the entire environment, I can recreate the entire the same environment in a matter of minutes. So yeah. So this is what I was trying to cover. Yeah, I guess we still have 15 minutes of time. So the last point that I wanted to cover is the integration with Azure DevOps pipeline. So in the Azure DevOps pipeline, I have created a project called Azure Virtual Azure Community Day. and there is a pipeline. So I've already checked in everything and everything there. So if you look at my Azure pipelines.yaml file, you will see that I'm actually using Terraform tasks there. So what I'm doing here is I'm actually using Azure RM, and then like provider as Azure RM using command init, and then I'm specifying the subscription. I'm specifying the backend, everything. So everything will be taken care by the by the by the Azure DevOps itself. So let me go ahead and try to, okay, I should zoom in, I guess. Yep. So let me edit this pipeline. Yep. So edit pipeline. So in the edit pipeline, I can say that, like, for example, for this case, if I'm going to search Terraform. So if you see in the init command, you can specify the Azure subscription, resource group, storage account, and everything, and it will override everything that you had configured here in the backend. So that's how you can configure it in Azure pipeline. But by default, you'll not get this Terraform task. So the Terraform task needs to be installed. So for that, you'll have to go to the marketplace. Marketplace.visualstudio.com, and then there's a plugin called Terraform Task. I think it's created by Microsoft. Oh, not this. Sorry. Yep. If you search for Terraform, yeah, there's a task for Terraform. So that's created by Microsoft Developers. So you can just install it in your DevOps pipeline, and then use it. So as you can see here, the first task I'm doing here is init. The second task that I'm doing is apply. So I'm not planning or anything because I'm not running that in the local. But what I'm doing here, I'm passing the var file. So, but this is just for the demo. Actually, you don't need. It's not a good practice to use check in the variable names in variable values inside the repository. But I have done this for the sake of demo. You can reuse the variables of the Azure pipelines and then like configure it instead of doing it in the file based. So what I'm going to do here is I'll run this pipeline. I'll just run it from the master branch, and if you see here, if you check my main.tf is the same that I was doing in my local, and then I can do it. If I look at the pipelines, I can see the logs of whatever is happening. I think it should be much faster than my local machine because it's running in Azure itself. Yeah, it's trying to initialize it, and it's applying it, acquiring state log. So whatever that I did in my local, it will be reconfigured and reapplied in the Azure resources itself. So if I see here, it's not trying to create resource group. It is trying to create the app service plan and everything. So yep. Let's wait until this happens. I'm monitoring the. I'm kind of monitoring the chat in my phone here, but yeah, looks like there is a lot of going on there. But yeah, I'll come back to that in a while. So yeah, it says the app service plan creation is completed. Let's see. Let's make sure that the logs are not lying. Yep. So my plan is being created. My app inside is being created, and it's trying to run everything. So okay, so it's the same thing that happened in my local. So it's going to take a while, but yeah, let's not wait for it. So yep, I think I covered everything that I promised, and we are still in time. We still have 50 minutes left. So yep, yeah, I'll look at the chats in a while. But if you have any questions and if you want to reach me at Twitter, it's there, and you can find this slide at this link if you want to look at it. So let me see.
JT will actually read out the questions for you, Ravi.
Okay, that's
so,
right.
Because there were a bunch, and I also feel like I found my community in the chat, so I'll be sticking around, and I hope that you join us in the chat as well. That'd be awesome.
Sure.
I think there were a couple of really good questions and discussion in the chat, Ravi. I think the first one that I'd love you to talk a little bit about was if you need to store secrets or credentials for something within Azure, obviously with something like Azure, you'd want to store them in a key vault or something like that. How do you push them through to a key vault using Terraform without actually storing those secrets in the code itself? Is that the same as the way that you did the ARM template key, or is there another way to manage that? How does that work? What does that look like?
So yeah, for that, my understanding is that if you want to push key vault secrets and stuff in the using Terraform, then you can create a variable. What I would do it as I would create a variable, and then I would reference that in the key vaults, and then I'll push that I'll push that variable's value using Azure pipelines or something like that, so that I don't store it. Or like for example, what it really depends upon what your secret is, right? So if your secret is something like SQL database connection string or Azure storage access key, then you could actually reference that reference directly from the infrastructure. So you don't have to manually handle all the secrets by yourself. You could actually reference that in the infrastructure, in the code itself, like I did before while I was setting the app service plan ID and something like that. So that's the one way. The other way is like to use the pipelines variables and then like push that to the Azure Key Vault using this. So that's something that you can create. You can take a look at the providers, the documentation for Azure Key Vault in Terraform, and then like I believe there's something that we can find.
Awesome. The second conversation that I thought was kind of interesting is Terraform obviously does a bit of state management for you. How do you manage promotion of different deployment environments? So if you start out with a dev environment, you want to deploy that same infrastructure to test before your application goes out and then on to prod. What does the process for doing that look like?
So for that, as I showed how we can use Azure DevOps pipeline to create resources. So in Azure DevOps, you can actually manage multiple environments as well. So you can have dev, test, and then dev test, and then production environment. So and then you can have all the stuff configured there, and then you can create a build. You can create the artifacts out of it, and then after using that artifacts, then you can use that artifacts and deploy that to dev first. Then you can use the same artifacts to deploy that to test, and then like do the production. So you can use the environment management capability of Azure DevOps, and then you can use Terraform there. So that's how would I do if I wanted to do that.
Awesome, thank you. Flor, did you have anything else that you wanted to add before we thank Ravi and send him on his way?
I did think that there was also someone who suggested using GitHub instead of DevOps. Is that something you tried out as well, Ravi?
I haven't tried it out, but as far as I know, it's completely possible to use GitHub Actions and then GitHub for using the Terraform. So it's not locked into a Microsoft Azure ecosystem or whatever I showed in the demo. It's just for me, it was a bit easier to do with Azure DevOps because I'm well versed with it. So yeah, we can still use GitHub Actions and GitHub to do whatever we did here. So it's not locked into Azure DevOps or Microsoft Azure itself.
Absolutely, thank you. I think we're up for a little break, and then we're back with a session on enterprise bots. And thank you so much for joining us, Ravi.
Thank you very much. Thank you very much for having me. Yep. Bye-bye. Have a good day.
See you later.
Bye-bye.